Hello everybody, Obadiah Cole here. Today, I'm going to do a little fun thing with a fun little device tool called Arduino Uno. Arduino is a series of pre-made circuit boards with microcontrollers on them that allow you to do cool, fun, fancy, funky stuff. That might not have made sense, or it might. This is not going to necessarily go into deep advanced stuff right now. It's just going to be basic, very basic level of things. I used to be very good at making things with these boards. I used to do projects all the time back in high school. However, it has been a little bit of time since I last messed around with them, played around with them, at least in just a, kind of doing stuff sort of way, other than research, work, sort of stuff. In order to get myself back into it, I'm going to be going through this book. It's by Make, Getting Started with Arduino, 3rd edition. I have read through this book in the past some. I don't think I've gone through the entire thing. I don't know if I will go through the entire thing this time, but I am going to at least go through basics of it, so then that way I can get the practice of getting into it again. And if you're watching, go ahead, try along, or it can be a thing of you will be able to get an idea of some things you could possibly do with this, at least in a very introductory, beginner type level sort of thing. For those that don't know, this book goes over Arduino Uno, and then I believe also Leonardo, which is a different type of board. I do not have one of those, so I'll mainly just be using the Arduino Uno, which this is it. I don't know how well the camera is focusing on this or how well you can see it. I'm gonna hope it shows well enough. This is a version of it. Usually you see a large black piece right there, which is like this one here. It's just a different model version of it. There's not really any difference other than the physical parts of it are bigger or smaller. At least I don't think there's any other difference than that. Getting into it though, we gotta start by reading. So, here we go. Where is page 1? Here is page 1. Arduino is an open-source physical computing platform for creating interactive objects that stand alone or collaborate with software in your computer. Arduino was designed for artists, designers, and others who want to incorporate physical computing into their designs without having to first become electrical engineers. The Arduino hardware and software is open source. The open source philosophy fosters a community that shares its knowledge generously. This is great for beginners as help is often available geographically nearby and always online. Chapter 2, The Arduino Way. So I've actually already read a little bit of this. There is an interesting addition in this part of the book that it talks about circuit bending, and that is something where you take an already existing circuit. I am looking around to see if I have one on hand. I do not see one. Actually, here. This is my mirror that I use on my board, or on my wall. It's made from a circuit board. It's not too reflective, but it's kind of the metaphor behind it that makes it a mirror. You have to get close enough to actually see it. So you have to get close to a person to see who they really are. That's the idea behind it. Not a lot of people really get that. I tell them that's oh yeah, that's my mirror, and they're like, what? That's not a mirror. That's what? But so this is a circuit. If I had this attached to some sort of power source, battery, whatever, and I essentially just took some piece of metal or wire and touched 2 points together that shouldn't normally touch, it will have some sort of effect. A good one, a bad one, who knows? That is the art of circuit bending. You essentially just short out the circuit in different ways. You can add resistors, add other components, stuff like that in there, and some sort of effect will happen. I don't not recommend it. I endorse, if you do try it, I endorse being safe about it, because some circuits, if the right connections are made, components can explode as well as catch on fire. There can be risk of electrical shock, stuff like that. So be safe. Wear safety goggles. One time I made a circuit and I accidentally overloaded an LED, and it just shot up, hit me right here. And if it had just been 1 inch over to the left or the right, it would have hit my eye. I probably would have had to go to the ER, maybe lost vision. It wouldn't have been good. But I got lucky. Don't count on yourself necessarily being lucky too. Back to the main point. Basics of Arduino. So this is the board. The actual board is this whole physical thing. The microcontroller is a specific part on the board. For this version, it is that little black square right there. For this one, where it's the bigger chunk, it's that big strip, which I'm covering up the top because I don't know if there will be potential like legal ramifications if I show it. So I'm just gonna be cautious about it. The Arduino board, Arduino Uno, it has a series of pins. So like this black strip of this black strip and this black strip up here, it has holes all along inside of that. On this top part here, that is the input output. They're the digital input output pins, or I/O is short for input output. These input output pins, they can receive or give some sort of electrical signal. Now, these being digital, they will only receive one of two types, which is high and low. And from what I remember, I believe that high and low corresponds to essentially on or off. So like if you know any binary, or if you know any meaning of binary, it is a 1 would be high and a 0 would be low. On the bottom, there is this little strip here. That is the analog input. Analog is essentially taking the raw electrical signal data, so like the raw voltages, currents, all that, and it takes those values and it just takes them as what they are. Now, it will not exactly be perfect because it does have to convert from that analog to some degree of digital, just because of hardware limitations. That's how these things tend to work. It can be very useful for certain projects if you need to know specific values or like certain ranges of values, rather than it just being high or low. And then on the digital input output side, there is also, you probably can't see it for sure with this, but there are some pins that have little squiggly lines next to them. I believe it's called a tilde. Those little squiggly lines, those indicate which pins allow for analog input or output. There. Did I just be output? No, sorry. It's only analog output. My fault. And it will be pins 3, 5, 6, 9, 10, and 11. What that means is that those pins, if you use them for something, you can output some sort of electrical signal that is not just high or low. It can have something between 0 and 255 is, I think, the upper limit. And then other important information is the way that it's powered. It can either be powered by USB, which this metal big block here has a little plug. This is the adapter. Plug it on in, and as you can see, it is now turned on because it's plugged in my computer. And I just realized, since my USB port is on that side of my computer, I'm probably going to be holding this upside down a lot. At least please know that for future reference. Then it can also be powered by that thing there, that little black bit. There is essentially a cord that you can plug into there, and there will be batteries that you can turn on and off with that. I have one somewhere. I do not know exactly where it's at. I should probably find that though. And if there is a power source in this black part, it will, if there is both a power source in this black part and a USB port plugged in there, then it will prioritize using power from the power source before using it from the USB. That is, I believe, the most important things really about what you have to know about the physical board to actually kind of get started. The next biggest important thing is, how do you actually use this? Now, the way that these are used is you, as described before, you can plug them into through a you can connect them to a computer using a USB cable. The reason why you want to do that is because these boards, the microcontroller, the black part on there, that you can program in order to get the board to do various things you would like them to do. So, in order to program, you need some sort of software, an integrated development environment, or IDE for short. You don't really necessarily need to have that memorized or whatever. It's just the software that you use to write down the core. It's just the software that you use to write the code and then upload it into the physical hardware, the physical board that you'll be using. The software used for this is found, you may find it online on Arduino's website. I forget exactly what it is. I'll possibly put a link in the description. It might also be a thing where once you plug in whatever board you have, it'll just kind of automatically install. I don't know. I don't quite remember because I've had this installed on my computer for a while. So let's take a funnel look at it. When doing this, the first thing you're going to really want to do is select whatever board you're having connected. So it'll be this little drop-down thingy. For me, it is the Arduino Uno in COM4. COM4 essentially means whatever USB port it's plugged into. If you have multiple boards plugged in, that's when that really matters more. Sometimes there might be some sort of error, like with what port you have it in, where it's like some connection is not working. That's not normally an issue, but in case that comes up for you, that's where you can find that sort of thing. Going back to the book, really getting started with Arduino. We actually get to using it. All this build up for this. There is an important bit that actually the book brings up, which I haven't really thought about too much, the actual terminology, but with these sorts of things, there are two sorts of devices that you can connect to them. They are sensors and actuators. Sensors, they take some sort of information like, oh, it's this bright out here right now, or oh, there's some noise, which, by the way, that noise, I'm printing out a prototype. Just please ignore that. I hope it won't be too loud in the actual finalized video. The other one, actuator, that is something that takes an electrical signal and it brings things out into the real world. So this LED here, if it were to light up, I believe that would then make it an actuator because it would be bringing light into the world. There are also various types of motors where, you move them. Pretty cool, you do stuff. Back into here, the book instructs to go up here to File. Oh wait. I skipped a step. I'm sorry, I skipped a step. We need one of those LEDs. So, take an LED, and I'm gonna stick it in to pin labeled 13. And this, with an LED, the two leads, the two metal bits here. One of them is longer, one is a little shorter, and that indicates the positive negative sides. It is the shorter side is the negative. Yeah, the shorter side is the negative side, and the longer side is the positive. So in here, it'll be connecting. The longer one will go into pin 13. The shorter one will go into will connect to the one labeled G and D, which stands for ground. As you can see, it's plugged in. Nothing's happening. Nothing weird. Nothing normal. Well, I guess this is normal. In here, then, we go to examples, and then basics, and then I think blank. I think I can do blank, and yes, blank. Window popped up, and it just has all the code. It's that. I'm gonna make another video that actually goes into this code, and it'll be like writing it, but to show the board working, it'll be, I'm going to verify it, which essentially goes through the code, make sure that it's all valid and good, and then you upload it to the board, and then once it uploads, you will see this LED begin to blink, just like that. It's pretty cool, isn't it? Yep, I think so. I think it's pretty cool. All I had to do was I pressed like 3 buttons, and then boom, I have a blinking light. I didn't even have to write a lick of code. Not even the tiniest lick there is. Well, right now I think that's all for this one, for doing this. I hope it is a good and acceptable, very basic start to this. I'm gonna be going through some of these examples, and I'm actually gonna be typing through the code. I'm gonna be showing more than just a blank, a screen of, oh, here's an example, let's upload it. No, I'm actually gonna talk about it. I'm gonna figure out what we can do. We're gonna find the limits. We're gonna see if we can break those limits and see what goes on. Hope you're having a great day. Hope you're having a great time. Hope you enjoyed this video, and I will see you next time. Bye.